Let's do a word problem. This is a great application of Lagrange multipliers, a business style word problem. So by investing X units of labor, Y units of capital, a watch manufacturer can produce P of XY as 50 times X to the 0.4, Y to the 0.6 power watches. Find the maximum number of watches that can be produced on the budget of $20,000. Labor costs $100 a unit, capital costs $200 a unit. Okay, so what's going on here? And before I do anything else, let me just say that this is actually this kind of function here, x to the 0.4, y to the 0.6. If you study economics, this is actually a very reasonable model for this kind of problem. Well, for Lagrange multipliers, we need f of xy, and we need g of xy to be a constant here. F of xy, this is just the thing that we're trying to produce here. So I'm just going to, 50 x to the 0.4, y to the 0.6. Find the maximum number of watches that can be produced on a budget of $20,000. So something is going to equal $20,000. If labor, X units of labor costs, $100, $100 unit of labor plus $200 per unit of capital. So this is our Lagrange multiplier setup. Here's our f of xy. Here's our constraint. As we could move the 20,000 to the other side. Let's not worry about that. Okay, so what do we have to do here? Well, let's just start crunching things through. We know from our Lagrange equations right here, we need to do the gradient of f. So the gradient of f is equal to, we crunch this out here, the partial derivative of this expression with respect to x is going to be 50 times 0.4 times x to the negative 0.6. Subtract 1 from the exponent. 0.4 minus 1 is negative 0.6 times y to the 0.6. The partial derivative of this expression with respect to y is 50 times 0.6 x to the 0.4 y to the negative 0.4. And we want this to equal lambda times the gradient of g. And the gradient of g, the x partial derivative is 100, the y partial derivative is 200. Okay, so we have equations here. What are our equations? 50 times 0.4, so that would be 20. X to the negative 0.6 times, times y to the 0.6 is equal to lambda times 100. And 50 times 0.6, that would be 30. X to the 0.4, y to the negative 0.4 is going to equal lambda times 200. Okay, so how do we go from here? So one thing that we can do is that we can solve both of these for lambda, move the 100 and the 200 to the other side. So we have lambda is equal to the same thing, and then we get, then we can have set the two equations equal to each other. So we divide both sides here by 100. We get 20 divided by 100 is 1/5. X to the negative 0.6, y to the 0.6 is equal to lambda. Divide both sides here by 200. We would have 30 over 200 would be 3 over 20 times x to the 0.4, y to the negative 0.4 is equal to lambda. And I said these two things, lambda is equal to this, lambda is equal to this. So we must have 1/5 x to the negative 0.6, y to the positive 0.6 must equal 3/20 x to the 0.4 times y to the negative 0.4. Okay, so now we need to solve these equations here. Let's clear out the decimal. Let's clear out all of the decimal exponents and the negative exponents here. Let's multiply both sides of our equation by x to the 0.6 times y to the 0.4. There's x to the negative 0.6, and we multiply by x to the positive 0.6, y to the negative 0.4, so we multiply by y to the positive 0.4. When we do this, okay, 1/5, this times this, those cancel, y to the 0.6 times y to the 0.4 is y to the first, is equal to 3/20. X to the 0.4 times x to the 0.6 is just x to the first. Y to the negative 0.4 times y to the positive 0.4 is going to just be 1. And so we have simplified this down a heck of a lot. And this is going to give us 1/5 y is equal to 3/20 times x. And multiply both sides by 20 to clear things out. If I multiply both sides by 20, I get 4y is equal to 3x. Okay, so 4y is equal to 3x. Now the other thing that we haven't used yet, we have not used this equation yet. So now it's about the time to do that. 4y is equal to 3x, and we multiply, let's just multiply both sides of this by, let's multiply both sides of this by 50. 200y is equal to 150x. Why did I do that? Because I just see a 200y in here. So 100x plus 200y, but 200y is 150x, is equal to 20,000. So this is 250x is equal to 20,000. And if we divide both sides by 250, I didn't do this ahead of time. I should have, I think that's 80. Okay, so x is 80. We still haven't answered our question yet. Find the maximum number of watches that can be produced. We have the x value, now we need the y value, and then we plug into our original function to get our desired answer here. So y is equal to 4y is equal to 3x. 4y is equal to 3 times 80. That's 240. Y is equal to 60. And so our final answer here is going to be P of 80, 60. So that is 50 times 80 to the 0.4. So we're using this right in here times 60 to the 0.6. Okay, so this is once again a nice Lagrange multipliers question here. One thing to know is that there's many different ways to solve these. I can't show you every single trick to solve them, but you just have to practice these until you learn lots and lots of the tricks for how to solve the systems of equations here. And again, it's a nice little applied, in this case, an economics applied problem. Okay, here's a good pre-class problem for you to try. Here's a good pre-class problem for you to try here.